Come on in and don't be late. Let's learn science with Mr. Ed U Cate. G'day students, we're out and about in the school grounds right now. I know you missed this school. Here's a random tree that I found because it's got lots of leaves, and leaves are organic, they're living, they're made up of organic compounds, and so therefore they're made up of all hydrocarbons, every bit of it. There's no other element but hydrogen and carbon. Or is that right? Let's go and see if there are other elements involved in organic compounds. What was I so upset about in the photo before when I was pointing at this molecule here? Well, I think I was upset because I was hoping that all organic molecules were made up of only carbon and hydrogen. But no, there are other elements in organic molecules too, like oxygen, nitrogen, even chlorine and fluorine and the other halogens. So let's check this out. Well, here we are, we're up to 9.2 functional groups. In this little section, we're going to be looking at functional groups, their structures and names, functional groups that contain oxygen, nitrogen and other halogens. We're going to be looking at their IUPAC nomenclature, how to name these classes of organic compounds like alcohols, ketones, esters and amides. We're going to be looking at their structure and names, and we're going to be applying IUPAC nomenclature to name complex organic compounds that contain more than one functional group. So zip up and enjoy the ride. Well, I'm going to try to give you a really quick rundown, a quick summary of this whole section, section 9.2, starting on page 226. Let's start by revisiting these side branches, hydrocarbon side branches that we called substituents last video. So here's our main chain. It's got 6 carbons in it, and we've got these side branches. This is an ethyl side branch and a methyl side branch. I better start using the right term, substituent. It's called an ethyl group and a methyl group. Well, this lesson today, we're going to be learning about things that are a little bit like a side branch, a little bit like a substituent, but they're not called substituents, they're called these things, functional groups. And let's revise some of the basic hydrocarbon family with just 2 carbons. This 2-carbon hydrocarbon doesn't have any multiple bonds, just single bonds, so it's ethane. 2-carbon hydrocarbon starts with eth, eth, finishes with ane because it's got single bonds. This has got a double bond, so it has the suffix -ene. Starts with eth still because it's got 2 carbons, so ethene. And same story with ethine. So it's got a triple bond, suffix -ine, prefix eth, 2 carbons. So these are just the hydrocarbons. But let's get a quick overview of this next section from the point of view of the ETH family. Well, in this section we're looking at functional groups, sort of like side chains, sort of like substituents, but not hydrocarbon based. Here's the first one. Here's ethanol. Ethanol is an example of an alcohol or an alkanol. Here's the side branch as it was, the OH. That's called the hydroxyl group. Here's another one. Ethanol. Ethanol is an aldehyde. You might have heard of that family of compounds before. Ethanol, 2 carbons, but its functional group is this one here, a carbon double bonded to an oxygen. That's on page 227. This next one here is an example of a Alkyl acid or carboxylic acid on page 228. This is ethanoic acid. It's got 2 carbons, So eth, and it ends in ethanoic acid because it's got this functional group. A carbon double bonded to an oxygen, and that same carbon is also single bonded to an OH group, a hydroxyl group. That's an alkanoic acid functional group. The next one, ethyl amine. This is ethyl amine. It's an example of an amine. The functional group here is that one, a nitrogen attached to two hydrogens, and that nitrogen is attached to the main chain. Here we go. Here's the next one. This is an amide. This is ethanamide. It's on page 229. It's like an amine. It's got NH2, a nitrogen attached to two other hydrogens, but that nitrogen is attached to a carbon that's involved in a carbonyl functional group like before. The next one. This is an example of a nitrile. This is ethane nitrile. You guessed it, that's the nitrile part. It's an example of another functional group, carbon triple bonded to a nitrogen. They're both happy as far as bonding goes. Carbon's got its 4 bonds, it's got a valency of 4, and nitrogen's got a valency of 3, like in the one above here. 1, 2, 3 sticks going away from nitrogen. So that's a nitrile. Another functional group you'll be looking at in this chapter is a haloalkane. Halo, because it's got a halogen, in this case chlorine. Ethane. It's basically ethane, but instead of one hydrogen, one of the hydrogens being bumped off, and chlorine takes its place. Chloroethane is a haloalkane. So that's the functional group there, chlorine. And the two other functional groups we're going to be looking at in this, one other functional group we're going to be looking at in this chapter, this section, is an ester. This is an ester. You might have heard of esters. Esters are actually the group of compounds that are responsible for the fruity smell of fruits, like mangoes and citrus fruits have their peculiar smells because of esters. This example of an ester involving 2 carbons is methyl methanoate. Typical name for an ester, and by the way, all these names are IUPAC names. An ester is a carbonyl functional group. Carbon double bonded to oxygen. That same carbon is bonded to an oxygen. That's an ester functional group. And the last example here is actually a mixture of 2 of the others. We've got a hydroxyl group here from an alcohol, and we've got a carboxylic acid group, or an alkanoic acid group from an organic acid. Here we've got 2 functional groups in the one molecule. In case you're wondering, can you have more than one functional group in the same molecule? The answer is yes. You can have 2 or more. Some molecules have 3 or even 4 functional groups. This particular molecule, I tried to find one that was only 2 carbons long, but I chose this one because everyone knows about lactic acid. Here's lactic acid. It's an acid because it's got the acid part, a carboxylic acid functional group, and it's also got a hydroxyl group. That's the common name. That's the common name, and this is the IUPAC name. 2-hydroxypropanoic acid. So really, that's this whole section in a nutshell. If you wanted to hang around for a bit more to have a look at each of these functional groups in depth, hang around. Well, let's look at the first lot of functional groups containing oxygen. But what is a functional group first? Well, let's have a look at the definition on the left-hand side of the page. By the way, we're up to page 226. A functional group is an atom or a group of atoms in an organic compound that determines the reactivity of that compound. Like I said before, it's a bit like a side branch, and it actually defines the chemistry of that compound. The hydroxyl group are found in alcohols. This hydroxyl group can be located on any carbon in the main chain, and to name alcohols, it's pretty simple. You just replace the final letter E and replace it with ol. For example, instead of hexane, you might have hexane 2-ol. 2 because the hydroxyl group would be, in this molecule, would be attached to the second carbon. Let's try to name one alcohol. Let's name an alcohol that's found in worked example 9.2a. So here we are. This is our alcohol. It's got 1, 2, 3 carbons in the main chain. There's no other carbon there. This is the OH group, the hydroxyl group, and it's attached to what looks to be the third carbon, but because it's the main functional group in this molecule, it's located on the first carbon. Don't forget, this molecule is three-dimensional. You can flip it around. If you flipped it around so that the other way, so that this functional group's on the other side, it'd be the same molecule. So that's carbon number 1, carbon number 2, carbon number 3. So that'd be, it start with prop because it's got 3 carbons. 3 carbon hydrocarbons start with prop. 1-ol because the hydroxyl is attached to the first carbon. Well, you might have asked, what's if this hydroxyl group was attached to the second or third carbon? Is that possible? And it certainly is. When it's attached to other carbons, it may become a secondary or tertiary alcohol. So let's look at these 3 main types of alcohol: primary, secondary, and tertiary. A primary alcohol is when the hydroxyl group is bonded to one other carbon, and that carbon is bonded to only one other carbon, or none in this case. So this is methanol. 1 carbon, meth, and ol. This one here is a secondary alcohol. A secondary alcohol is when the hydroxyl group is attached to a carbon, this pink carbon in the middle, and that pink carbon is in turn attached to or bonded to 2 other carbons at the same time. Whereas a tertiary alcohol has the hydroxyl group attached to a carbon that is attached to 3 other carbons. So let's try naming this and this alcohol. So with this one here, this secondary alcohol, the hydroxyl group's attached to the middle of 3 carbons. It's got 3 carbons, so it's got to start with prop, and the hydroxyl group's attached to the second carbon, so it must be propan 2-ol. What about this one, the tertiary alcohol here? Well, it's still got 3 carbons in the main chain. It's got another carbon here, but that's in a methyl group. So this alcohol would be, let's have a go. This would be 2-methyl because this methyl group here is attached to this second carbon, this middle carbon. 2-methyl propan 2-ol again. 2-methyl propan 2-ol. Let's have a look at the next functional group, known as the carbonyl group. Carbonyl group. The carbonyl group is found in both aldehydes and ketones. And by the way, you might have heard of those 2 classes of compounds before, but they're not the IUPAC name. The proper IUPAC name for aldehydes is alkanals, and for ketones, alkanones. You can see this on page 227. Just to save me time though, I'm just going to explain what I'm going to do as a shortcut from now on. This here is the compound butanol. It's got 1, 2, 3, 4 carbons in it, so it's bute. Not bute as in beauty, mate, but BUT. and it's got a carbonyl group in it that it's at the end carbon, a terminal carbon. So it's butanol. We'll go through that again later. But up until now I've shown hydrogens at the end of each bond there, either side of each carbon. But from now on I might omit the hydrogens. So if I've omitted the hydrogens, just assume that the hydrogens are there. And also if there's another way of even shortening it down even more by not drawing the sticks either side of the carbons. So all of these, that one, and that one, three different ways of drawing butanol. But here's another one. Generally, I could even abbreviate this down even further by using the capital letter R. The capital letter R is used to designate any hydrocarbon chain. Could be any length. Could be 1 carbon long, 2 carbons long, 3 or more. In this case, 3. So generally, this is still any type of alkanal or aldehyde. So as I said before, aldehydes and ketones both have the carbonyl group, where a carbon is double bonded to an oxygen. Let's have a look at aldehydes first. Aldehydes. In general, an R group, any hydrocarbon chain attached to a final carbon that's involved in a carbonyl group situation. Aldehydes is when the carbonyl group is located on a terminal carbon, a carbon at the end of the main chain. Here's an example. Let's have a go at naming this aldehyde. How many carbons does it have? 1, 2, 3, 4, 5, 6. It's got 6 carbons. Why did I number it from 1 this side to 6 that side? Well, that's where the main functional group's found. You number your carbons that have the functional group as the lowest number. This is a terminal carbonyl group, and so it would be 6 is hex, and rather than hexane, you replace the E with an L, hexanal. So that's why we call them in general alkanals, not aldehydes. What about ketones? Ketones are pretty much the same. It has a carbonyl functional group, but the carbonyl functional group involves a carbon that's not a terminal carbon. It's an internal carbon. So let's number so how many carbons in this one? 1, 2, 3, 4, 5, 6. 6 again, so it's hexan something. And it must end in -one because it's got a non-terminal carbon. So it's all to do with the numbering again. Let's number them this way because this will, if we number them from right to left, it'll give the carbonyl group the lowest carbon number. So this will be hex and 3-one, hexan 3-one, because the carbonyl group's attached to the third carbon. Well, the next thing that we're going to look at is the carboxylic acids. We don't want to get confused here because carboxylic acids are a class of organic compound, but the functional group that makes up a carboxylic acid is a carboxyl group. A carboxyl group is where you have a carbon, 2 oxygens and a hydrogen attached to the main chain, or more specifically looks like this: carbon, 2 oxygens and hydrogen. So it's like a carbonyl group, a hydroxyl group, all in one. They're both together as a carboxyl group. So let's have a go at naming this one here. The main chain has 3 carbons in it. The carboxyl group, this one, is attached to a terminal carbon, which it has to. A carboxyl group is never found in the middle of the main chain. So 3 carbons long. You must start with prop, and you replace the ane with propanoic acid. So the IUPAC name is actually, for this class of organic compounds, is alkanoic acids. And so the IUPAC general name reminds us of how we should name these compounds. It should end in anoic acid, propanoic acid. What about that one? What would that be? Yep, pentanoic acid. All of the compounds that we've been looking at so far consists of functional groups that contain oxygen, and this is another one, esters. Esters are a class of organic compound that are derived from a carboxylic acid, this part of the molecule, and an alcohol, this part. The ester functional group, the actual ester functional group, I guess, is that part there. It contains a carbonyl group, that one, carbonyl, carbon double bonded to an oxygen, and the other part of the ester functional group is an oxygen attached to another carbon of whatever length. And by the way, R can be any length of carbons, and R stroke could be the same length or different, whatever. It's different hydrocarbons at both ends. So that's the ester part though. Let's actually name this ester here. Let's have a go at naming this ester. To name an ester, you've got to assign the carbon in the carbonyl functional group as carbon 1. So it's carbon 1. That'd be carbon 2. Step 2 is to count the number of carbons in the chain attached to the carbonyl group and name the chain and add the suffix -08. So that would be it'd be normally ethane, but that's ethanoate. The third step is to count the number of carbons in the chain attached to this oxygen. So there's the other oxygen with single bonds either side, and the carbon chain attached to that oxygen is 2. Okay, name the chain and add the suffix YL. So that's another 2 carbon long chain. So that'd be, instead of ethane, it'd be ethyl. So it'd be ethyl ethanoate. So this molecule is ethyl ethanoate. So that's the alcohol part. Whoops. The alcohol part, and this is the carboxylic acid part. You always name the alcohol part first and with a YL, and the acid part second, ending in 08. So far we've been talking about organic compounds containing oxygen. They were alcohols with this functional group, aldehydes and ketones with the carbonyl functional group, and the carboxylic acids with the carbonyl functional group, and the esters with the ester functional group. Well, next we're going to look at the organic compounds containing nitrogen, not oxygen this time, starting on page 229. They include 3 main compounds that we're going to look at. You might have heard about them: amines, amides, and nitriles. And these are the functional groups that make up each. Let's have a look at them now. Let's move on to the amines, the first of the nitrogen-containing organic compounds. Well, amines and amides and other compounds are very important organic compounds, especially in biological systems. Amines and amides are derived from the molecule ammonia, which of course is NH3. So the nitrogen comes from the ammonia molecule. The only difference between ammonia and the amino functional group, or the amine functional group, is one or more of these hydrogens have been replaced by an alkyl group. An alkyl group. Just have a quick revision of what an alkyl group is. An alkyl group, we call them substituents in the last section, Examples of alkyl groups are methyl, ethyl, propyl, butyl. Remember that? It's just hydrocarbon side branches pretty much. So amines contain the amino functional group. The amino functional group, like the ammonia molecule, consists of a nitrogen atom bonded to 3 other things, and those things can either be hydrogen or an alkyl group. There's 3 types of amines: primary, secondary and tertiary amines. Primary amines is when the nitrogen is attached to only one alkyl group. Like in this situation here, this nitrogen is only attached to one alkyl group, the alkyl group being designated by the capital letter R. So there's only one R attached to the nitrogen there, so that's a primary alcohol amine. Don't get it mixed up with alcohols. And what are the 2 dots up here? Well, it just reminds us that, remember, nitrogen has a valency of 5. It's from group 5. It's got 5 electrons in its outer shell. One of these is shared with one of these carbons. Another electron from nitrogen is shared with a hydrogen, another with the other hydrogen, so that's 3 so far that came from nitrogen, plus 2 more make 5. And so that's why we've got 2 lone pair of electrons at the top there. So what are secondary amines? Secondary amines is where the nitrogen is attached to 2 alkyl groups, like here. Here's one alkyl group, here's another. Could be the same, could be different, so I've just separated the 2 by putting a stroke next to one of the R groups and a hydrogen. So you guessed it, tertiary amines is where the nitrogen is attached to 3 alkyl groups, like here. 1, 2, 3 alkyl groups. And let's have a look at an example here. Let's name this compound and figure out what class it is. Well, firstly, the class, pretty simple. This nitrogen is attached to 1, 2, 3 alkyl groups. Notice there's no hydrogens. Notice that the nitrogen's not directly attached to any hydrogen. They're all alkyl groups here. That's a methyl group. That's an ethyl group, and that's another ethyl group. And by the way, a lazy way of drawing that same molecule. It's a different way, not a lazy way. The way that we've been looking at it up until now is this. This is the ethyl group, methyl group, and the other ethyl group. There's 1, 2, 3 hydrogens there, CH3, and there's 2 hydrogens here, CH2. It's a different way. It's another way of writing it, and it's the easiest way. Less sticks to draw. Oh, we've got to name it, haven't we? Okay, so let's name it. It always ends in amine because it's an amine, nitrogen attached to 3 other things, whether they be hydrogen or alkyl groups. Now let's just have a look at the alkyl groups. There's 2 ethyl alkyl groups and 1 methyl. We name them by naming each of the alkyl groups in alphabetical order. And don't forget to include the multiplier. In this situation, the multiplier is for ethyl groups. There's 2 of them. So this becomes diethyl, running out of space, diethyl methylamine. Diethyl methylamine. 2 ethyls, 1 methyl. Let's move on to the next nitrogen-containing compounds known as the amides. Amides are derived from carboxylic acids. It contains 2 parts, a carbonyl functional group directly attached to an amine functional group. So the whole thing becomes an amide. So this is the carboxylic acid part, and this is the amine part. So carbonyl to amine. And like the amines and the alcohols, we have primary, secondary, tertiary amides as well, just to complicate things a little bit, but it's all easy. A primary amide is where the nitrogen is only attached to one other carbon. Primary, one. Nitrogen attached to one carbon, and that carbon is the carbon from the carbonyl group. So the other two things that the nitrogen is attached to is just hydrogens. Secondary amide, the nitrogen is attached to two carbons, 1, 2. The second one from this R group. And remember, all these, whenever you see an R, it stands for an alkyl group, a hydrocarbon chain, or a substituent. And tertiary amides is when the nitrogen is attached to 1, 2, 3 other carbons. So let's have a go at naming an amide. And if this really tricks you up, you can always find it on page 230. They give you another worked example there. But I tried to pick a pretty complicated one, as complicated as you'll ever get. Let's go through the steps in naming this one. So the first step, as indicated on page 230, is to identify the main chain. The main carbon chain is this one. So that'll start with, it's got 5 carbons, 1, 2, 3, 4, 5. So it'll consists of the word prefix pent. The second step is to number the carbonyl carbon. This one, remember, carbon double bonded to oxygen is carbonyl. Name that as the first carbon. So 1, 2, 3, 4, 5. And next step is to add the suffix amide after the pent. Penton, I should put amide. So penton. If you forget, if you just put pent amide, that's wrong, because remember, you write the alkane part, pentane, but the E is replaced with amide. So it's a pentanamide. The next step is to use the word N. The capital letter N goes at the very start. The capital letter N is used to represent bonds to the nitrogen atom in these complex type of amides. So the locant N indicates that there is an alkyl group. Here we go. Here's the N in the actual molecule. There's an alkyl group, this one, attached to the nitrogen. This alkyl group, it's got 2 carbons, so it's ethyl. So it'll be N, ethyl, pentanamide. And I wrote this too far away from that. So N, ethyl, pentanamide. It's the name of that one. Well, the next and last organic compound that contains nitrogen are the nitriles. Nitriles are a class of organic compound that contains a functional group consisting of a carbon triple bonded to a nitrogen. So this one here is the nitrile functional group. So how do we name this particular one here, this particular nitrile? Well, the carbon atom in the functional group is carbon 1. As always, the carbon in the functional group is given the lowest number carbon. So that'll be 1, 2, 3, 4. There's 5 carbons. And because it's got a nitrile functional group, the name will actually finish in nitrile. The name will actually finish in the suffix nitrile. And so we've got a 5 carbon main chain, and with a carbonyl functional group, and we've got a a methyl group coming off the second carbon. So this will be 2-methyl pentane nitrile. You retain the E, okay, in pentane, so you write down the full parent chain, main chain hydrocarbon, pentane. You indicate the alkyl group that's attached to the number carbon, and finish with nitrile, 2-methyl pentane nitrile. Hanging there, we're almost there. Another class of organic compounds contains halogens. These are known as the haloalkanes. And this title actually indicates how we name the haloalkanes. Halogens, of course, are the chlorines, the fluorines, the iodines, any element from group 7 in the periodic table. Let's have a go at naming this one. The halogen is always mentioned as the prefix in the name, so this would be bromoalkane. Count the number of carbons in the parent chain. We've got 1, 2, 3, 4. We'll number them this way. I can number them. I don't know. Number them this way is the best because the bromine has to have the lowest number. Bromine is the functional group here, so this would be 2-bromo. That's 4 carbons long. Butane, 2-bromobutane, 2-bromo. So you replace the letter O with the ene, and there you go. What about this one? Well, this is a one carbon molecule, so it must end in methane. It's got 3 chlorines attached to the same carbon, so we call this trichloro. Run out of space here. Trichloromethane. Oh, we didn't actually. Trichloromethane. So the multiplier is used to denote how many alkanes in the haloalkane. Well, thankfully we're at the last little section of chapter 9.2 now, looking at polyfunctional compounds. We're looking at organic compounds with more than one functional group. Like in the case of lactic acid I showed you at the start, there's the carboxylic acid group and a hydroxyl group. Now, what do you do in naming this type of compound with more than one functional group? When you've got 2 functional groups, there'll always be a principal functional group, the main one, the boss one. The principal functional group in this case is the carboxylic acid, the carboxyl functional group here, and it takes precedence over all the others. It's mentioned as the suffix of the name, so because that's the main one, it'll be propanoic acid as the suffix because there are 1, 2, 3 carbons in the main chain, and this hydroxyl group is named as 2-hydroxy as the prefix. So how do you know which one is the principal functional group, like this, and which one is the subordinate one, the secondary functional group, like this one? Well, if you go to page 231 in your textbook, this table here, table 1, shows the order of priority of functional groups and polyfunctional compounds. Carboxylic acids are actually at the top, then esters, amides, nitriles, blah, 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 all the way to the bottom, alkanes are the least. So if you had a nitrile and ketone in the one molecule, it would end this. The name of that molecule would end in nitrile because it's the principal functional group of the two, and the suffix would, the prefix would be the ketone oxo. So in this table, it shows you what to use as the prefix in this column and the suffix in this column. Gets pretty complicated, but if you've got this table with you, you can't go wrong. So don't forget to have a go at these Check Your Learning questions on page 231. Wasn't sleeping. Don't blame me if you were sleeping. That was a heck of a long section. 40-minute video. It's going to take a while to get through. But hey, don't worry. That section 9.2, was huge. And the one before that, massive. But it sets the groundwork for the next couple of sections, 9.3, 9.4, which are really tiny, really easy, and really fun, actually. We're going to be building some models with that one. And look, by the time we get to our next big section, you'll be back in this very room. Can't you wait? I've had it by myself all this time, but it's not the same without you guys. I'm missing you. Come back soon. Baby, come back!